Let's discuss the relationship between K sub C and K sub P. So our equilibrium constant when it's expressed in terms of concentration and pressure. So it turns out there's a relationship between the two. And both the ideal gas law and the definition of molarity is the two pieces of information we'll use to find this relationship between the two. So recall this is our ideal gas law, PV equals nRT. If we rearrange this equation to solve for P, which is pressure, we end up with N over V times RT. And N over V is just number of moles over volume, which is concentration or molarity. So I just substituted Mn for N over V. You could also substitute in C for concentration, right? M for molarity, C for concentration means the same thing. So this is what pressure equals in terms of concentration. Now let's go back to this example reaction that we've been looking at. And let's start with our equilibrium constant expression in terms of pressure, right? Where we have the pressure of our products raised to their coefficient over the pressure of our reactants raised to their coefficients. So now if we plug in the relationship that we found in the last slide, which is pressure equals MRT, we can plug in MRT for everywhere we have pressure. So our pressure as it pertains to our product C, right, is equal to the concentration of C times RT raised to its coefficient. So we plug this in for every single product and reactant. So then we can rearrange it to where we have just our concentration of our products and the concentration of our reactants raised to their coefficient times RT raised to X plus Y over RT raised to M plus N. So this is a mathematical rule that we're using here, right? Because we're multiplying. Basically, if we're multiplying two things raised to a coefficient or raised to an exponent, it's the same as multiplying those two things and then adding the exponent, right? So this is a math rule that we're able to use here. And the reason we want to rearrange this as it is because you may notice here that this is our equilibrium constant expression as it pertains to concentration. So this is actually Kc here. This is K sub C. So if we plug in K sub C and then using our mathematical rule here for RT raised to an exponent over RT raised to another exponent, which would just be RT raised to the difference of those exponents, this is what we have here. Now, because these exponents are our molar coefficients, right? It turns out that it's basically just the change in the number of stoichiometric coefficients, right? It's the change in that. So it's the difference of the sum of the coefficients on our product side minus the sum of the coefficients on the reactant side. And we can just represent that as delta N, delta N. And delta N just means the number of moles, right? The number of moles, the change, or I'm sorry, the difference in the moles of our products and reactants. So this is our equation where we can relate K sub P and K sub C. This is the equation that actually relates the two.